Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0616, signifies a low-voltage condition in the starter cut relay diagnosis circuit for the Honda Civic models produced between 2011 and 2015. This issue primarily hinders the vehicle's capability to start, as the starter cut relay plays a crucial role in controlling the starter motor's activation. The starter cut relay is located within the underhood fuse relay box, serving as a critical component for starting the engine. When this circuit detects a voltage of 2.2 volts or less, the system interprets it as an error condition. Hence, it prevents the engine from starting until the underlying issue is diagnosed and rectified. This diagnostic guide outlines troubleshooting steps to effectively identify and resolve the P0616 code, ensuring that the starter relay's functionality is restored. The error associated with DTC P0616 revolves around the starter cut relay that restricts voltage to the starter motor. The relay's role is pivotal, as it ensures that the starter motor receives the correct voltage at the right time to engage effectively. In a Honda Civic, the starter cut relay is situated within the underhood fuse relay box, which houses several electrical components critical to the vehicle's operation. The powertrain control module, PCM, interacts closely with the starter cut relay, ensuring that the vehicle starts only under safe conditions. The relay and its circuit must be functioning optimally. Otherwise, a voltage drop below the required threshold of 2.2 volts can lead to starting issues. Understanding both the location and function of these components is essential for efficient troubleshooting. Several potential causes can lead to the P0616 code being triggered in a Honda Civic. First, poor connections or loose terminals found at the starter cut relays or within the connections to the PCM could result in a significant voltage drop, leading the system to detect an error. Next, if the starter cut relay itself is defective, it may not be able to activate correctly, which again would reflect an erroneous low voltage reading. Furthermore, a malfunctioning software version in the PCM could also contribute to erroneous voltage reporting and behavior. Therefore, thorough inspection of electrical components, connections, and the programming in the PCM is vital in addressing the DTC P0616 and restoring proper function. Symptoms associated with DTC P0616 typically manifest most prominently as starting issues. The vehicle may refuse to start altogether, which can be frustrating for the driver. In some cases, the engine might start intermittently, leading to uncertainty about the vehicle's reliability. Additionally, during diagnostic checks, voltage readings may indicate a drop to 2.2 volts or lower at the starter cut relay, confirming the underlying issue. Drivers may also notice other electrical components behaving erratically, which can sometimes accompany starting issues. Recognizing these symptoms is crucial, as they guide both the technician and the vehicle owner towards identifying the cause of the trouble code effectively. The first troubleshooting step requires pressing the engine start-stop button to engage the vehicle in on mode. This will allow for initializing the vehicle's electrical systems and preparing for diagnostic checks. After that, it is essential to clear any stored diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. This step resets the system and prepares it for a fresh diagnosis. Following the clearing of the codes, the next action involves checking the starter cut relay through the HDS. Specifically, if the diagnostic measures below 2.2 volts at the starter cut relay, this failure can be duplicated, indicating a persistent issue. These foundational steps are crucial in both verifying the problem and establishing an effective direction for further troubleshooting. For the second troubleshooting step, Ensure the engine is in off mode by pressing the engine start-stop button accordingly. This is essential for safety and proper measurement of electrical components. The next step is to inspect fuse number A5, which has a rating of 7.5 amps and is located within the underhood fuse relay box. It is important to verify whether this fuse is intact. If it is blown, it can cause a complete failure in the starter cut relay circuit, resulting in the P0616 code. If the fuse is operational, you'll advance to the next step of the troubleshooting process. However, if the fuse is defective, replacement is necessary before continuing on. Upon selecting the on mode by pressing the engine start-stop button, it is crucial to repeat the check on the starter cut relay using the HDS. This helps confirm if the relay is receiving sufficient voltage. If the readings show 2.2 volts or more, this indicates that the relay is operating correctly at this stage. A proper voltage measurement confirms that your diagnostics are pointing towards potential issues in the wiring or connections elsewhere in the circuit. Conversely, if the voltage remains below 2.2 volts, this result necessitates further investigation and possibly leads to the next troubleshooting steps for resolution. The importance of verifying voltage levels cannot be overstated in diagnosing electrical failures. In the fourth troubleshooting step, you will again press the engine start-stop button to select the off mode for safety and to allow for component testing. Proceed to remove starter cut relay 2 from its position in the underhood fuse relay box. This is necessary for testing the relay's functionality directly. Once detached, the next task is to conduct a test on starter cut relay 2 to verify if it's operational. It should visibly click and conduct electricity if functional. If you determine that starter cut relay 2 is working as expected, the next step will likely involve replacing the underhood fuse relay box, as the issue may stem from there. However, if the relay proves to be faulty, then it will need to be replaced to restore proper functionality to the starting system. In the fifth step of troubleshooting, begin by setting the engine to off mode. This will prepare your assessment of the wiring further in the circuit. Utilize the Honda Diagnostic System, HDS, to jump the SCS line, facilitating a controlled diagnostic process. Proceed by disconnecting the PCM connector A, which has 51 pins. With the connector removed, measure the resistance between two specific test points: the number 24 green wire from the PCM connector and a solid body ground. If the resistance is found to be 1.0 megaohm or more, it confirms that there is no short in the wiring between the PCM and starter cut relay connections. In instances where the resistance fails to meet this threshold, it indicates that a short exists in that section of the circuit, and repairs will be necessary before proceeding. Following the completion of all necessary repairs related to the P0616 code, it is essential to verify that the vehicle system is functioning as intended. Begin by testing the system functionality to ensure the engine starts reliably and operates smoothly. Additionally, confirm that the previously recorded diagnostic trouble codes, DTCs, have been cleared and no new ones appear during diagnostics. This step reassures that the issue has been accurately resolved. Consistent performance should be monitored for several days to ensure stability in starting ability and to rule out the potential for recurrence of the issue. Thorough final checks can provide assurance that both the driver and vehicle will experience reliable performance moving forward. To prevent the recurrence of DTC P0616 in the future, it is vital to integrate some routine preventive maintenance into the vehicle care practices. One of the main areas of focus should be regular inspection of the wiring associated with the starter cut relay to ensure there are no signs of wear, fraying, or potential shorts. It is also a good practice to conduct periodic checks on the fuses located in the underhood box, ensuring that they remain intact to prevent starting issues. Equally important is ensuring the PCM software is up to date, as discrepancies or outdated firmware could lead to miscommunication between components. By taking these proactive measures, drivers can significantly enhance the operational reliability of their Honda Civic and minimize the chance of encountering issues tied to DTC P0616. In summary, addressing DTC P0616 requires a methodical approach to verify symptoms and identify underlying causes effectively. By following structured troubleshooting steps, it is possible to pinpoint whether the issue pertains to a defective starter cut relay, poor connections, or issues within the PCM itself. Each step provides crucial insights, leading to a comprehensive understanding of the specific failure within the starter circuit. The importance of verifying connections and checking voltage levels cannot be overlooked, as they are key indicators of system health. Moreover, implementing preventive measures can contribute to sustained reliability, ensuring that the Honda Civic operates signably well for the owner long-term. Consequently, attention to detail in maintenance and diagnosis will keep starting issues at bay and enhance the overall driving experience for Civic enthusiasts. Please like and subscribe to the channel. See you next time!